All right, so we are number 6 on the notes today. So still solving systems, but now we're going to stretch it out. So now we've got 3 equations and 3 variables. So it's a jumbo size solving equation, basically system type thing. All right, and there's a couple of different ways that you can do these. We're going to show you what, to me, what seems like the easiest thing to do, just because of how it sets up and what we'll do. The book may show just a little different version of this one, but to me, this is, I always try to give you all the easiest thing that I can think of that I figured out, so I always kind of go with this one. So, all right, so step 1. You're going to eliminate one variable from 2 equations. So we're still going to do elimination. You still just pick what you think would be the easiest variable to eliminate, just like we were doing before, and you're going to eliminate one of the variables from 2 of the equations. We're not doing all 3 equations at one time. We're doing this in pieces. All right, and when you do this, when you add these 2 equations together and eliminate this one, we're just going to say that's like a new equation 1. All right, step 2. Here's the key thing with step 2, and this is the part that if you get this one, it's okay, because sometimes people don't get this one part, and then they're like, what do I do then? Like, well, you got to start over because of how this is. You have to eliminate the same variable. And that's the key thing. It's got to be the same variable that you did from step 1. And this time you're using a different equation. Or we'll say a different pair of equations. Okay, so pick one variable you think that's easy to eliminate. Do that in 2 equations. And then you eliminate the same variable with a different 2 equations, a different pair of equations. And when you do that one, this is your new equation 2. Okay, so in this case, we've got 2 variables here. Now, if we eliminate a variable here, now we've got 2 variables here. You've got 2 variables here. Now you can take these 2 new equations that you have. So we're going to solve the 2 new equations by elimination. Now, you can do substitution if you like substitution. Most people, when we've done this in years past, most everybody's like, I don't like substitution. I want to do elimination because I don't have to worry about distributive property. I don't have to worry about multiplying by negative. I don't have to worry about doing. So we're just going to say we're going to do elimination. And once you solve that 2 new equations with elimination, then you're back to just basically now you're doing this just like we did on Monday, 2 days ago. Now you've got 2 equations with 2 variables. You're going to solve it just like a regular elimination problem. And then you're going to use substitution to find all 3 variables. And again, when we're talking about the substitution, this case, this is when you're already going to have like x equals 2, and you're going to take that value for that first variable that you find, and then just plug it back in to find all the other different values that you have here. Okay, so really all we're doing is it's the first two steps that are new because you have to eliminate one variable, and then second step is you eliminate the same variable, but you got to use a different pair of equations. And once you do that, steps 3 and 4 is what we were doing on Monday. That now you've got two new equations with two variables. You just solve that by elimination. If you want to do substitution, you can. Does anybody more comfortable doing substitution, or does everybody kind of like elimination? Elimination, okay. And again, if you want to do substitution, you can, but most people kind of seem like everybody's like, I don't like elimination because it just lines up better for that part of it. Okay, now before we do that, before we actually give you a full blown, equation with everything that's here, probably one of the very first things that you're going to have is you're going to have a system where they're going to go ahead and give you a system. And once you've got the system, they're going to ask you, okay, is this a value? Is this one true? Does this fit into the system that we're looking at? So this will be just kind of we're going to back up for just a second to make sure you know what happens here. Okay, and instead of having ordered pairs, you're going to have ordered triples because now we've got three values. So we're going to have like X, Y, and Z in most cases. And so in that case, they're going to give you a value. Instead of saying an ordered pair, now they're going to say it's an ordered triple. And so they're going to give you an ordered triple instead of an ordered pair and just ask you, okay, is this thing a solution for this part? All right, so it will look something kind of like this. Okay, for the Z's, I'm going to go ahead and put a slash through it so it doesn't look like a 2 because occasionally I'll have a 2 that looks kind of like a Z. So I'm going to put a slash through the Z's here. X plus 2y. Okay, and in the homework, they're either going to give you X, Y, Z, or they'll give you A, B, C. Which order triplet doesn't really matter when it comes down to it. Just these will always be in order alphabetical wise. So this is going to be your X, this is going to be your Y, this will be your Z. If they give it to you in A, B, C, then this will be A, and then that'll be B, and that would be C. All right, so if they ask you, is this thing a solution? All you're going to do is you're going to take these numbers and you're going to plug it into each equation and see if it's true or false. So now we're looking at lines that are going to meet out in space. So we're still looking to see if all these lines meet at the same spot. So what you have to do is go ahead and plug these numbers in to each of the equations. And for it to be a solution, it must make each equation true. So each equation must be true when you plug in the values for X, Y, and Z. Okay, if any one of them is false, if you plug in the numbers and it doesn't match up here for this one or this one, if any one of those gives you something that doesn't make any sense when you plug it in, it's going to be no. If it's going to be true, then every single one of these numbers, when you plug it back in, has to make the equation true. Okay, and again, just to make sure that we're okay with these, a lot of times when we're doing these, especially when we're doing examples here, out beside it, I'm going to put like E1, E2, and E3, just because it makes it easier when we start talking about what it's going to be for these. Okay, so just take the values you got here and just start plugging them back in. If you plug it into equation 3, it's -1 minus 3 times 0 plus 2 times 3 equals -6. Okay, so that gives us what? 3? Oh, wait, sorry. Whoops. It's -1. That's 0, so that's out. That's gone. Doesn't matter if it's plus or minus. Plus 6 equals 6. That's -1 plus 6. That's 5. 5 equals 6. That's no. So if it doesn't fit here, it doesn't matter what it does back here. They ask us, is this a solution? If that's not true, then that thing's not a solution. Okay, so anytime they give you an ordered pair, they can even do this like in some of the homework for the graphs if we're doing inequalities. They may give you an ordered pair and ordered triple and have you just plug it back in. And if it makes it true, then it is. If it doesn't, then it's false. Question? Wouldn't that be -6? Oh, it is -6 over there. Sorry, I left the negative off there. I'll bet. Okay, so 5 does not equal -6, so still a no. Okay. Okay, so if you get one of those, it's pretty straightforward. Just take the numbers you've got, plug it back into each equation, and if you get no at any point in time, you can just stop and say it's no. If you get yes on the first one, go to the second one. If you get yes on the second one, go to the third one. If you get a yes on the third one, then the whole thing is yes. But if any one of them is no, then you can stop and you're done. Okay, so for this one, now we'll actually do one like full blown where they don't just give you an order pair or order triple to plug in. This time we'll actually solve the whole thing here. Okay, and just like it's been with all the other systems, they'll say just solve. All right, so let's go x minus y plus z equals -1. We're going to go x plus y plus 3z equals -3. 2x minus y plus 2z equals 0. This one, yeah, this is where we're going to go back through all the steps. This one, it just says it doesn't give us a point to plug in, so we're going to go back through all the steps on this one. So, all right, now when you're solving these, now to give everybody a chance to kind of get everything written down, so they weren't trying to write while I was talking. When you're doing these, you want to look for the variable that's got the least amount of work you're going to have to do to eliminate it. So, like over here, if we're going to get rid of z, you're going to have to take this equation, multiply it by -3 to eliminate this one. And then if we work with the z again, the easiest one to work with would be we take out the middle equation, equation 2. Well, then you got to take this equation, multiply it by -2 to cancel this one. Same thing over here with the x's. You can multiply this one by -2 to cancel this. But if you look at the y's, what happens if we put those two equations together? We got plus and minus y, right? That'll cancel right off the bat. If we put the bottom two equations, we've got plus and minus y. They cancel without having to do anything, right? And that's what you're trying to do is you're trying to see, okay, which equation or which variable can I get rid of without doing the least amount of work for this thing? So basically you want to find the ones that already have all the same numbers on it, and that's going to be your easiest one to kind of pick. So for this one, now there's no right or wrong way. If you said I want to get rid of the x's, that's fine. which one you get rid of first, it does not matter. It's just you have to pick the one you think is the easiest. So in this case, we're going to eliminate y. Here's the thing. You got to do it twice. Okay, so for the first time, let's just put these two together. Let's put equation 1 and equation 2 together because it's already a plus and minus y. So let's just add equation 1 and equation 2 together. All right, so if we just bring those over, that's x minus y plus z equals -1. And then x plus y plus 3z equals -3. Okay, now here's what I'm going to tell y'all, and this is honestly where I've seen people make more mistakes than anything else. People will get here and they'll make simple little mistakes that they'll say, all right, I'm doing x plus x, that's x. But is x plus x really x? Because remember, you got to have ones in front of these, right? So it may be something really, very, very simple, but everywhere you've got just a letter, you might want to go back and put a 1 there because that's 1x plus 1x. That's 2x. And I've seen people do that, just get in a hurry because, oh, the x plus x is x. And they'll not stop and think about it. So on those, just don't get in a hurry. Just go back and put 1s there. This is 1 minus 1, so that's 0, and that's what we want because it's gone. This is 3 plus 1, so that's 4z. And that's -1 minus 3, that's a -4. Okay, so there's where we've done it once. We eliminated y once. Now we're going to do it again. And again, the easiest thing now is let's use equations 2 and 3 because we got a plus y here and a minus y here. So let's do equation 2 plus equation 3. All right, so that's x plus y plus 3z equals -3. And then 2x minus y plus 2z equals 0. Okay, again, sometimes it's little things. We'll go back, put a 1 here, 1 here, 1 here, and we're good there. Okay, so now we've got 1x plus 2x for 3x. Y cancels out, which is what we wanted. We got 3 plus 2 for 5z, and then -3. Okay, and then once you've got the two things where you eliminate the y's on this one, now you can forget about everything else for just a little bit. And through the magic of a projector, we get to do that. There it goes. Now everything else is gone. We're just going to work with these two equations. So all we're going to do is we're going to take these two equations and bring them back here and make them one little small system like we did a couple of days ago. The only difference is instead of being x and y, now it's x and z. But it's still okay. It's still just a 2x2 system. All right, and now we'll do this one like we did on Monday. We're going to either eliminate x or we're going to eliminate z just from this 2x2 system. There's nothing we can multiply to go from 2 to 3, and there's nothing we can multiply to go from 4 to 5. Again, without using decimals or fractions, which we don't want to do. So we said the shortcut is let's take this equation. We're going to multiply this one by 3 and this one by 2. Because that way we'll get 6x and 6x. The only thing is if we do multiply by 3 here, that is going to be 6x plus 12z equals -12. All right, and on the bottom, if you multiply it by 2, okay, that's going to be 6x, right? If this one's already positive, this one needs to be negative. So if it's going to be here, let's just go ahead and make it a -2, and that way we can do it all at the same time without having to go back and change the sign. So let's multiply by -2. So now we've got a -6x, which is what we wanted. We've got a -10z, and then we've got a +6. Okay, that will cancel. That's out. That's gone. Now we've got 2z equals -6. So z should be -3. All right, and again, just like we were doing 2 days ago, we're going to take this z for -3 and plug it back into any one of these equations we've got right here. Again, it doesn't really matter which one we pick, so let's just go with the one that's on the bottom just because it's closer. So we're going to take the z for -3 and we're going to plug it back in right here. Oh, sorry, that's 15. All right, so we've got 3x minus 15 equals -3. Add the 15 to both sides. So we got 3x equals 12. Divide those two out, so now we got x equals 4. Okay, so we've got x, we've got z. Now we got to go back to an equation that's got y in it so we can figure out what y is. And so now we're going to go back to, and I'll do it real quick here, going back to any one of these original equations back here, and we're going to plug in x and z just so we can see what's happening there. And again, there's no right or wrong on that one to pick. Let's just, I don't know, maybe pick the middle one. That we've got x plus y plus 3z equals -3. I'm going to plug in 4 for the x, and we're going to plug in z with a -3. Okay, so we know x is 4, we know z is -3, so we'll take those two numbers and plug it back into any one of the originals to help us figure out what y is going to be. All right, so that's 4 plus y plus 3 times -3 equals -3. So that's 4 plus y minus 9 equals -3. If you rearrange these and make it so it's y plus 4 minus 9 equals -3, you've got 4 minus 9, so that's y minus 5. And then run out of room here. So if we add 5 to both sides in this case, we get that y would equal 2. Okay, so final answer. Again, it's ordered triple, so there should be an x, you got your y, and you got your z. Okay, and the homework, there are not 15 of these problems because it takes a while. I think there's 4 or 5 of these. Yeah, I think there's 5 because it's, once you've done, a few of these, hopefully you got the hang of it. We don't have to do like 10,000 of these because they do take a little while to get through all these. Okay, I'm going to give you one more of these, and then we'll show you one. It's like a little bit of, I wouldn't say a trick question, but it's a different looking question, just to make sure that you're okay with what's happening with it. Any questions before we get to the next one? All right so far? Okay. All right, so let me give you one with the ABC just in case, because sometimes they'll mix in A's and B's and C's. I like X, Y, Z, but occasionally they'll get some A, B's, and C's. So let's do that. Okay, give you one that's a little bit more difficult, not like real bad, but just a little bit more difficult. That's what we're looking at. Okay, and here's what makes this one a little bit more difficult. We can put equation 1, equation 2 together. We can knock out the b. But if we go to the b's for this one down here, there's not an easy way to get rid of the 2 and 3 here or the 2 and 3 here. All right, if we try to get rid of a in the first equation, we got to multiply the bottom equation by -4, which wouldn't be too bad. If we want to get rid of a here, we got to multiply this equation by -11 to put these two together, which is not too bad. Okay, you can do that. If you go for the c's, you've got 1c and 2c, so you can multiply this equation by -2 and knock these out. Since this has already got a 1c here, you could take that equation, multiply it by -3, and get rid of those. So I think of the easier of the two, it's either going to be a or c that's going to be the easiest to get rid of. Okay, and the hint is usually if you don't have numbers that all match up, look for the ones that's got a 1 in it somewhere. If you've got a 1a or a 1c or a 1b, that's going to make it a little bit easier to work with that one just because it's 1 and it's easier to multiply with it being just a 1 there. So does anybody got a preference? Anybody want to get rid of a or c? All right, I'm hearing C. Got another C over there on the other side of the room. All right, so let's get rid of C. Again, there's no right or wrong for the first one you have to get rid of. You just have to pick the one you think is the easiest. So some people may look at C and think, I think C is easier, and some people may say, all right, I think A is easier. It doesn't matter. Just pick one and go with it. So we're going to eliminate C twice. All right, so if we use equation 1 and equation 2, if we're looking at C, we're going to take equation 1 and multiply it by -2. So we need to do -2 times equation 1, and then we'll add that to equation 2 to make it cancel out. So we're going to double everything in equation 1. So that's going to be -8a minus 6b minus 2c equals -46. Okay, in equation 2, we didn't change it at all. So that's just a minus 3b plus 2c equals -8. Okay, again, I know it's a small thing, but you may want to go ahead where you got just the a. Just go back and put a 1 because, again, I've seen the temptation before that people will just kind of go, oh, that's just -8a and a, and they'll just tell me it's -8. No, it's -8 plus 1, so that's -7a minus 9b equals -54. Okay. Again, sometimes it's those little things that make all the difference. So, where you've got just a letter by itself, I'd still go back and put a 1 there just so that you don't, especially if it's been, for some of y'all that took the last math you had was geometry, and that was a year ago. If you started taking it like in August and September last year, if you go back before that, for some of y'all, it's been 2 years since you had Algebra 1. So, just to kind of make sure you're comfortable here in the beginning, I'd go back and just put 1s on everything if you want to. You can even do that back up here in the beginning. You can put a 1 here, and you can put a 1 there. And that's kind of where you want to look at it. If you see a 1, again, this was good for the B's, but that's not going to be good for getting rid of that B. Anywhere you see a 1, that should make that part easier to eliminate that variable. So either one of these two should make it easy. Okay, so for the C's, picking a different pair, let's go with these two because we've got 1 and 3. So then we can take equation 1 and multiply it by -3 and add that to equation 3. And y'all can't see that because I didn't pull my paper far enough. Okay, here we go. So we're going to take equation 1, multiply it by -3, so we get a -3c, and then we're going to add that to just the 3c that was there. Okay, so taking everything in equation 1 and multiplying it by -3, and I'm just going to have to slide this up because it's too far up there. That's going to be -12a minus 9b minus 3c equals -69. Equation 3 is 11a minus 2b plus 3c equals 3. Okay. And it's always good to go back and double check, especially when we're doing this when they're kind of spread out. 11, -2, 3, 3. Yeah. Okay. All right, so then put them together. It's -12 plus 11, so that's -1a. And I'm okay putting the -1 there, just for a little bit, just to make sure we got it. -9 minus 2 is -11b. That's going to equal -66. All right. Again, it never hurts just to pull down a 1. We can always get rid of it later. All right, so now we've got these two equations with just a and b, so we're going to put them together and just solve those two equations. All right, so we've got -7a, pull it up so y'all can see it there, minus 9b equals -54, -1a minus 11b, and -66. All right, I know which variable I want to get rid of here. It's going to be the easiest one in those two to eliminate. The one with the 1, right? Yeah. So the a should be easier because in this case, we can just take this equation and multiply it by -7 because this is already -7. If we multiply this by -7, that'll make it a +7. All right, so if we do that, that's a 7a plus, now it's going to be a little bit big here, 77b equals, and I don't know what that is, that's 6 times 7 is 42. That's another 42. We're going to add a 4. That's going to be 462. And if you're not sure, take out your handy dandy calculator, just double check it. There we go, 462. Okay, so we're good there. All right, and then the top part, we didn't change it. We left it just like it was. All right, so the a's are gone. We've got 77 minus 9. Should be 68b. We've got 462 minus 54, which is 408. And if we divide that by 68, comes out nice and easy that b is going to equal 6. Okay, now here's the other thing too. I picked homework problems that should give you whole number answers because there was a couple of homework problems where it was like the answers were like 11 over 12 and 16 over 35. And it was always like, ooh, that's a little extra. So let's just, you should get whole numbers when you go through these. If you don't, then you may want to go back and check your numbers. Just make sure you got it. Okay, so now we're back to b equals 6. Pick any one of these equations, plug it back in. Let's see what a is going to be. About the same either way, right? So I'm going to just pick the bottom one here. So I got -1a minus 11b equals -66. We're going to plug in this b equals 66 right here. So -1a minus 11 equals 66. So that's -1a minus 66 equals -66. And if we add 66 to both sides, we get -1 equals 0. And the only thing you can multiply to get 0 is 0. Okay. And remember, some people might be thinking, I thought that was undefined. No, it's undefined if you don't have a variable. If you get to the end and there's no a here, if it's just -1 equals 0, that's undefined. But y'all won't get this in this case. You will get an answer for every single one of these. There's no trick questions here. You could have that, but I'm not going to do that to you because to work this out and get to the end and realize it's no solution would be cruel. That'd be kind of mean. All right, so then we'll take this one and this one, And I'm running out of room, so I'm going to go to another piece of paper. So now we're going to take A equals 0. We're going to take B equals 6. And we're going to pick one of these three equations here and plug it back in. I think the middle one looks okay. Seems like it's got the smallest numbers, so we'll go with the middle part. So that's A minus 3B plus 2C equals -8. Okay. So with this one, we're plugging in these two numbers. All right, so A is equal to 0. Plug it in, which is easy because it knocks that out. B is equal to 6, so that's -3 times 6 plus 2C equals -8. So that's -18 plus 2C equals -8. We're going to add 18 to both sides. We're going to scoot that up so you can see it. So that's 2C equals 10. So finally, we get that C is equal to 5. All right, so ordered triple. We've got A, B, and C. All right, let me show you one more that's a little different, and it's actually, they've already done some of the work for you. Just because it looks a little funny, and sometimes people will get thrown off a little bit when they see this one, but let's just make sure everybody's good here. This one shouldn't take as long as the other ones because it's got something missing, which makes it go a little bit faster. All right, so for this one, we'll go x minus 2y is equal to 1. We've got x plus 3y plus z equals 0, and then 2x minus 2z equals 18. All right, and sometimes people get thrown off on this one because they're like, well, hey, there's stuff missing. There's a y missing here, and there's a z missing here. That's actually good because what that means is they did step 1 for you. So when a variable is missing, not that it's really missing, but it's just, there's not x, y, z in all three of them, then basically step 1 is done for you. And you can pick which one you want to eliminate now because they've eliminated y here. So we can eliminate y here, or they eliminated z here. So then we're going to eliminate z here. Okay, so if they've done step 1 for you, they eliminated y with this one, we need to eliminate y with these two, or they eliminated z here, we need to eliminate z with this one. As far as the numbers go and how they match up, because all the x's are here, so just forget those for a minute. I think z is going to be easier because this one we can just multiply it by 2, so we've got 2z and -2z. So let's just eliminate z. And for that one, we're going to do 2 times equation 2, and then add that to equation 3. Okay, so we'll take everything in equation 2, multiply it by 2. So that's going to be 2x plus 6y plus 2z equals 0. In equation 3, we'll leave it just like it is. All right, so now we've got 4x plus 6y equals, that goes away, and that is 18. All right, so now we got this one with the x and y. So now we can go back and use equation 1, which also had just x and y, and then put those two things together. So we're going to take this equation one we've got now and just drop it in here. So now we've got x minus 2y equals 1. Yeah, I messed up because I was writing that one in, so let me cover that up because I made a blobby there. Let's take out the blobby. There we go. So it's supposed to be just x minus 2y. I wrote something down wrong and messed it up there. All right, so now you've got just a regular 2x2 system. Now we're back to doing exactly like we were doing, 2 days ago. You can either multiply this one by 3 and make it 6y, or negative 6y to cancel with that 6y, or we can multiply this one by negative 4. Either way we go. Now, here's where, again, I'm going to kind of say from what I've seen in the past, if you can avoid changing signs and not multiply by negative, usually most people do better. So we could multiply this equation by negative 4, but a lot of times people forget about the signs. So for this one, let's just take this equation and then multiply it by 3. That way this will be negative 6x, and that'll be, or 6y, that'll be 6y, and then the y's will cancel. All right, so if we do that. What's that? Oh, so we had the 4x plus 6y equals 18 from putting this together. And then we brought down equation 1 and brought it back in here, which was back up here. So this was like the new equation 1. And this was the original equation 1. Because again, this one, and the original equation 1, they already had the z gone, so all we had to do was to make it so we had a new equation that didn't have a z, and then we could solve that one. So, okay, so now we're going to take the bottom equation, multiply it by 3. So we have 4x plus 6y equals 18. Multiplying the bottom equation by 3, now we've got 3x minus 6y equals 3. Okay, putting that together, we get, I'm running out of room here, so we're going to get 7x equals 21. So we get x equals 3. Okay, and then we'll take that x equals 3, plug it back into anything in here. I think, again, to me, that one's going to be the easier one to plug into. I'm going to go to another sheet of paper here. So we've got x equals 3. If we use x minus 2y equals 1, plug in the 3 here. So then we'll subtract 3. Divide those two, so then we get y equals 1. Okay, so we knew that x was equal to 3. We've got the y is equal to 1. And now we can go back to find one that's got z in it and plug it back in to figure out what z is. So if we go back to, now you can even pick the one that's just got 2 variables. We can use 2x minus 2z equals 18. Because you don't necessarily have to have the y. As long as you've got the x, we can plug that in to figure out what the z is going to be. So that's 2 times 3 minus 2z equals 18. So 6 minus 2z equals 18. We'll subtract the 6. And then divide by that. So finally we get z is negative 6. So again, ordered triple would be that. Okay, so it's a little bit quicker, may not be a whole lot quicker, but by them, again, anytime you get one where the variable is missing, it's going to make things go a little bit quicker. Okay, so that's a sort of a trick question ish, but you know what? It's actually a good question because they've eliminated some.
Can you read it back up the top?
Oh, yeah.
Like